Have you ever, spent maybe 3 hours brainstorming this massive, sprawling project with an AI, and you're meticulously feeding it all your requirements, only for it to completely forget, your most important instruction right at the very end?
Oh, it's incredibly frustrating.
Yeah,
I mean, you feel like you've wasted your whole afternoon.
yeah, exactly. But it turns out you're probably not using a bad model. You might just be, well, communicating with it the wrong way. So welcome to the deep dive. Today, our mission is highly specific and honestly pretty critical for your daily workflow. We are conducting a comprehensive, deliberate, step-by-step analysis of 10 critical practice questions for the CCAO-F exam.
Right, and mastering these concepts it's just non-negotiable for anyone using AI professionally today. Because we're going to look at the underlying mechanics of how these models actually, think, covering everything from the really granular details of prompt engineering all the way up to enterprise-level workflow design.
Yeah.
We basically want to move you from just sort of playing around with the tool to actually deploying it securely and effectively at scale.
Definitely. And for you listening, here is the structure for today's deep dive. We're going to take a very measured approach. We are going through all 10 questions from our source material in exact sequential order. So I will read the specific scenario from the exam absolutely verbatim. We will state the exact correct answer and its factual explanation. And then we're going to slow down, and really pull back the curtain on the why and the how behind each concept.
Really?
No skipping, no combining, just a thorough breakdown. So let's get into it. Question 1. A marketing manager notices that the model consistently ignores the instruction to keep responses under a certain length when handling very long background documents. Which troubleshooting step addresses this specific context issue?
The correct answer is A. Placing the length constraint at the end makes it more prominent after the model processes the long background document. This reduces the chance that the instruction will be overlooked because of excessive preceding context.
Okay, let's unpack this, because I know I've done this. Think about sending someone to the grocery store, right? If I hand you this massive, highly detailed 2-page list of ingredients for a dinner party, and right as you're walking out the door, I shout, hey, keep the total bill under $50, you're probably going to remember that budget.
Yeah, it's fresh in your mind.
Exactly. But if I casually mention the $50 limit an hour before we even start drafting the list, and then we spend 45 minutes debating which type of artisan cheese to buy, that instruction is entirely gone by the time you reach the checkout aisle.
That visualizes the concept perfectly. And in technical terms, we refer to this as instruction placement in long contexts. It really comes down to understanding how a large language model actually processes data.
Okay.
Because it doesn't read a document all at once, like a human taking in a photograph.
Yeah.
It sequentially analyzes tokens, words and parts of words. So when you place a critical instruction like a word count limit at the very beginning of a prompt, and then you follow it with, say, 10 pages of background text, you are heavily taxing the model's attention mechanism. By the time it reaches the end of that text and begins to generate an answer, the mathematical weight of that initial instruction has been severely diluted. I mean, just watered down by the sheer volume of the background data.
Wow. So the volume of the background information essentially drowns out the command?
Pretty much.
So for you listening, if you're dumping a 30-page PDF into a prompt, putting your instructions at the bottom feels, I don't know, kind of counterintuitive, almost like a postscript. But you're saying it's actually the most critical real estate.
Oh, absolutely.
Right.
It acts as the final guardrail before execution. Moving the constraint to the very end ensures it's the most recent, most heavily weighted directive in the model's active context window, just before it starts writing.
Okay, that makes total sense. And if placing instructions in the right spot is step 1, we need to look at how the system fundamentally ingests those 30-page PDFs in the first place, right? So let's explore that mechanism. Question 2. When designing a custom workspace where team members upload large policy manuals, how does the system process these attached knowledge documents during a conversation?
The correct answer is B. The system searches the uploaded knowledge documents and retrieves only the sections relevant to the current question. The documents provide supporting context but do not permanently train or modify the core model.
Wait, hold on. I need to push back on this a little just to clarify, because data hygiene is a massive concern for pretty much everyone.
Oh, for sure.
If I upload our unreleased top secret quarterly financials or, a highly sensitive employee handbook, are you saying the AI just forgets it? How can it read the document without its underlying brain learning from it permanently?
It's a vital distinction to make, and the concept here is called retrieval augmented generation. or a RAG.
Reg, okay.
Yeah, RG. And the reason your sensitive manual doesn't become a permanent part of the AI's brain is really because of how the architecture is separated. Think of it like an open book test.
Okay.
The core language model is the student taking the test. The manual you uploaded is sitting in a completely separate library.
So the student isn't memorizing the entire library.
Not at all, no. When you ask a question, a separate search algorithm goes into your specific uploaded library, finds the few paragraphs that match your question, and copies them onto a temporary index card.
Just a temporary card?
Right. It hands that index card to the student. The AI model reads the card, writes the answer, and then literally throws the index card in the trash. The underlying weights and parameters of the core model are never updated or retrained by your document. It's strictly a temporary referencing action.
Okay. That drastically lowers the temperature on the whole data panic thing. The model is just fetching index cards. Now, if the AI is fetching data locally like that, how do entire corporate departments utilize this at scale? Because it's not just one person asking a question anymore, it's thousands of operations running simultaneously. So, question 3. An operations team wants to move beyond simply generating draft responses and instead use artificial intelligence to categorize incoming requests, route them to the correct department, and draft the initial reply. This approach is an example of which workflow strategy?
The correct answer is C. The team is using AI across several connected stages, including categorization, routing, and response drafting. This represents a redesign of the overall business process around AI capabilities.
So we're shifting the AI from being a digital typewriter at the end of a process to being the entire factory floor.
Yes, and if we connect this to the bigger picture, this is AI-centered workflow redesign. Historically, a company might use AI as a bolt-on accessory.
Right.
Like a human would read an incoming customer email, manually decide, oh, this belongs in the billing department, forward to billing, and then a billing agent might use an AI to help draft a refund email. The human was the connective tissue there.
Right, doing all the heavy lifting in between the steps. But in this scenario, the AI itself is the connective tissue. But how does that actually work under the hood? Like, how does the AI actually route a message?
Well, it relies on chaining different models or prompts together via API connections.
Okay.
So stage 1 is an AI acting purely as a classifier. It reads the email and outputs a single tag, billing, tech support, or sales.
Just a tag.
Yep. And based on that tag, the system's logic automatically routes the payload to stage 2, where a completely different AI prompt specifically loaded with the billing department's knowledge base drafts the reply. You're tearing down the old human-routed infrastructure and building a fully automated assembly line.
That is wild. But I mean, handing over the factory keys means any flaw in the AI's logic gets mass-produced, right? Like if the AI learns a bad habit, it scales it instantly across the whole company.
That is the big risk, yes.
So let's test how to handle that. Question 4. During a hiring process review, a user notices the generated summaries of candidate resumes consistently highlight leadership qualities in male applicants while emphasizing teamwork in female applicants. What is the most responsible immediate action?
The correct answer is D. The workflow should be paused because the outputs show a potentially discriminatory pattern. Revising the prompt to require consistent job-related criteria helps produce more objective candidate evaluations.
Okay, let me play devil's advocate here for a second.
Sure.
If the model was originally trained on, I don't know, millions of real-world performance reviews and resumes over the last 50 years, shouldn't we just accept that historical employment data? I mean, isn't it just reflecting the reality of the training data?
It is reflecting historical data, absolutely. But historical data is a mirror of past practices, not an objective truth. And this is the absolute core of bias detection and responsible AI. If human hiring managers systematically use different adjectives for men and women over decades, the statistical model is going to map those exact correlations. If you let that run on an automated assembly line, you're taking historical biases and scaling them at light speed.
Wow. So accepting it means we are just automating our past flaws.
Precisely.
But how do we mechanically fix the prompt, though?
Well, you cannot rely on the AI's general intuition for hiring. The responsible action is to pause the workflow entirely and enforce objective criteria. You essentially rewrite the prompt to act as a strict grading rubric.
Like a checklist.
Exactly. You instruct the model, evaluate this candidate exclusively on their years of Python experience, their certification level, and their specific project management outcomes. You force the model to look for concrete data points rather than abstract qualitative summaries. It strips the ambiguity out of the automated process.
That makes total sense. So taking those strict rubrics and applying them to high-stakes, multi-layered problems is our next challenge. Let's look at complex analytics. Question 5. A financial analyst needs the model to evaluate a complex corporate merger involving multiple regulatory jurisdictions, financial risk factors, and timeline constraints. Which prompt structure yields the most reliable analysis?
The correct answer is A. Breaking the analysis into sequential steps allows the model to examine each jurisdiction, risk factor, and timeline requirement separately. This reduces omissions and makes the final analysis easier to verify.
So this is essentially the classic advice of eating an elephant one bite at a time, right? Prompt decomposition.
Exactly.
But I want to know why a massive, ultra-powerful AI model can't just swallow the elephant whole. Why does it fail if I just ask it to do everything at once?
It really comes back to cognitive load and attention mechanisms again. When you dump a prompt that simultaneously demands an analysis of, say, European tax law, Asian supply chain risks, and a 5-year fiscal projection, the model's attention is spread across wildly different domains.
Right.
The probability distributions it uses to predict the next correct word become muddy. It will inevitably hallucinate a detail, blend two different legal codes together, or completely gloss over a jurisdiction because it's just trying to juggle too much at once.
So it's kind of like asking a human analyst to simultaneously write 3 different reports with one pen.
That's a great way to put it, yeah. Precisely. By forcing the model to operate sequentially so, Step 1, analyze only the European tax law and output the result. Step 2, analyze the supply chain and output the result. You give the model's attention mechanism a narrow, focused target for each step.
And it doesn't get overwhelmed.
Right. And crucially, breaking it down like that allows the human financial analyst to verify the logic at each individual step rather than trying to untangle some massive, garbled essay at the very end.
Which would be a nightmare. Okay, so breaking down complex logic is vital, but what if the data you are feeding the system is just highly restricted? Like, corporate mergers are sensitive, obviously, but healthcare data is untouchable.
Very true.
Question 6. A healthcare provider wants to use enterprise artificial intelligence tools for analyzing patient feedback, but strict regulations require that no data is used to train the vendor models. How is this requirement typically addressed in enterprise agreements?
The correct answer is B. Enterprise agreements can explicitly state that customer data will not be used to train the vendor's models. This provides a formal data governance safeguard suitable for regulated organizational use.
Okay, hold on. A piece of paper is the bedrock here, because if I'm a hospital administrator, I don't care what a legal contract says if the vendor's servers get breached, or if the model absorbs my patient data anyway. How does a legal agreement actually govern the technical behavior of the model?
That is a very common skepticism, for sure. But an enterprise data privacy agreement is not just a pinky promise. The legal contract actually dictates the technical architecture that gets deployed for your organization. So when you sign a consumer-level agreement, you are using the public API endpoint, where your data might be logged for training. But when you sign an enterprise agreement, the vendor provisions a mathematically isolated environment. This is often called a zero-retention API endpoint or a dedicated private tenant.
So the contract literally forces the vendor to flip a technical switch on their servers.
Yes, exactly. The contract legally binds them to use architecture where your data passes through the model's weights to generate an answer, but is never written to disk or retained in the training logs. Without that formal legal and architectural firewall, regulated industries simply could not participate in the AI ecosystem at all.
Okay, that makes me feel a lot better about it. But even within those isolated, secure environments, the AI's internal logic can get pretty cluttered over time. So let's look at what happens when a session goes on just way too long. Question 7. After a long brainstorming session exploring multiple unrelated product ideas, the model begins losing track of the original constraints set at the beginning of the chat. What is the best architectural approach to resolve this?
The correct answer is C. A long conversation containing unrelated ideas can cause important constraints to lose prominence. Starting a new conversation with a concise summary creates a cleaner and more focused context.
See, here's where it gets really interesting, because anyone who uses AI has experienced this.
Oh, yeah.
You are an hour into a chat, you've gone down like 6 different rabbit holes, and suddenly the AI completely forgets the rules you established in the very first prompt. It feels like context management is basically just wiping down a messy whiteboard.
It is exactly like a messy whiteboard. Imagine a grueling 3-hour strategy meeting in a conference room. The whiteboard is covered in arrows, crossed out ideas, random tangents. If you try to start the next highly specific phase of the project on that exact same messy whiteboard, everyone in the room is going to be confused about what still applies. Language models experience a phenomenon often called being lost in the middle.
Oh, so their context window just degrades.
Exactly. As the chat log gets longer and longer, the model has to process the entire history of the conversation every single time you ask a new question. Eventually, the noise outweighs the signal. So the architectural fix is not to yell at the model or, buy a more expensive subscription.
Right.
The fix is to ask the model to summarize the best ideas, copy that summary, erase the whiteboard by opening a brand new chat session, and paste the summary. You establish a clean, highly concentrated context window.
Wipe the slate clean. Love that. But what if the confusion doesn't happen at the end of a long chat, but right at the beginning because you just handed it a massive data dump?
It happens all the time.
Let's see. Question 8. When designing a prompt that includes extensive reference materials, the model occasionally confuses the instructions with the reference content. What formatting strategy prevents this confusion?
The correct answer is D. Structural markers clearly separate reference content from the instructions the model must follow. This helps prevent statements inside the reference materials from being mistaken for operational directions.
So we are talking about structural delimiters in prompts. The old saying, good fences make good neighbors, applies heavily here.
It really does.
But mechanically, why does the model get confused in the first place?
Because to a language model, unstructured text is just one long, continuous stream of data.
Okay.
If you paste a 20-page policy document into the chat and buried on, say, page 14 of that document is a sentence that reads, always reply to customer complaints with an apology, the model's attention mechanism might lock onto that sentence. It might actually mistake a passive sentence inside your reference document as a direct command from you, the user.
Oh, wow. So it can't tell the difference between the material it's supposed to read and the orders it's supposed to execute.
Exactly.
So for you listening, how do we actually build these fences?
It can be as simple as using XML tags, literally typing the word document inside triangular brackets before pasting your text, and then closing it with a /document tag at the end, or even just using a line of hash marks. These structural delimiters act as physical walls in the prompt's architecture. They explicitly train the model's attention heads to recognize, hey, everything inside these brackets is passive reference data.
Yeah.
The commands to execute are outside the brackets.
You literally visually wall it off.
Yep.
Okay, now we've built the perfect fenced-in prompt. How does the system physically hand a complex answer back to us? Let's look at the output side. Question 9. A project manager is working with the model to generate a comprehensive interactive timeline for a software launch. Why would the system automatically present this result in a dedicated side window rather than standard conversational text?
The correct answer is A. A comprehensive interactive timeline is a substantial standalone deliverable rather than a simple chat response. A dedicated side window makes the content easier to view, edit, and interact with.
This represents a massive leap in user interface design. We were talking about standalone interactive artifacts, but how does this actually work? Is it just opening a split screen so I can read it better?
It's far more sophisticated than just a split screen. We're basically witnessing the shift from AI as a conversational chatbot to an active rendering engine.
Okay.
If you ask a simple question, text is fine. But a comprehensive timeline, a presentation deck, or a functional piece of software code requires a sandboxed environment. The system recognizes the structural complexity of the output and dynamically generates a dedicated workspace like a microbrowser or a code execution sandbox alongside the chat.
Because trying to read and format a massive timeline inside a narrow scrolling chat thread is just impossible. It is entirely the wrong container.
Exactly. The side window isolates the deliverable. It allows you to edit the underlying code, manipulate the timeline, and eventually export it as a professional asset without breaking the conversational flow in the main chat.
Which is huge for productivity. But, creating those professional artifacts is rarely a solo job. Getting a whole department to do it consistently is the real challenge.
It really is.
Question 10. A department head sets up a shared team workspace and adds custom instructions defining the corporate tone and brand voice. How do these custom instructions affect the daily usage of team members?
The correct answer is D. Custom workspace instructions function as persistent background guidance for conversations in that workspace. They help team members consistently follow the organization's preferred tone, terminology, and brand voice.
So persistent workspace instructions act like an invisible hand guiding the entire team.
Right.
But how do these differ from just telling my team to write good prompts, like giving them a style guide?
Well, if you rely on 50 different employees to manually type, please use a professional tone, avoid industry jargon, and reference our core values every single time they generate an email.
Yeah.
You will have total chaos.
Yeah, that's true.
People forget or they write conflicting instructions. Persistent instructions operate at the system level, not the user level.
Ah, so they wrap around the user's query silently.
Yes, they function as a hidden system message that prepends every single interaction within that workspace. The user just asks for the deliverable they need, and the system automatically applies the brand voice filter before generating the output. It solves the scaling problem by ensuring absolute organizational alignment without adding any friction to the employee's daily workflow.
Today, we've covered 10 crucial practice questions for the CCAO-F exam, analyzing the mechanics of instruction placement, RAG, workflow redesign, responsible bias detection, prompt decomposition, enterprise privacy contracts, context management, structural delimiters, interactive artifacts, and persistent workspace rules.